Hi everyone, welcome back to my channel. So in the last video we see how the computer lets you recognize the images, what are the red, green, blue channels, and how the colors let's see is presented to see the images. And in today's video I will show you how to read display the images using OpenCV and Pillow. So in a just few line of code, whether you are building the next, let's see, create a program, let's say in a computer vision application, or just want to automate it, let's say image processing. So today's session will give you everything you need to get started with OpenCV and Pillow. So by end of this video, you will be able to read, display, and manipulate and save also images using both libraries. Understand also when to use each one and have a toolkit, let's say practice. For this, you can also build your toolkit. This we will see in the how to do it in the next coming section videos. So now, before we can dive into the reading the images and also videos, we have in the first step we have to use to install the packages OpenCV and Pillow. Because I'm using Beauty, I have to add this. Why am I adding this sign here? Because I'm in a notebook, Jupyter notebook. If it's in a terminal, you have to remove this. And because I'm using this, so as you can see, a TOML file, it's already integrated here, Pillow and OpenCV. And this command will try to install it and save it in this file if they are not here. If you are using any other libraries, let's see Anaconda, you have to use this, or maybe another one with Kunda. So, and as you can see, when I run this, it will show us that everything is already installed. So now how to open images in step, what is the OpenCV? OpenCV is a computer vision open source, and it's fast performance and support many features like video reading. Many algorithms for the computer vision is already integrated, and the Pillow is just a friendly Python imaging library for, let's say, to make image task, let's say, easier. But mostly, if you are computer vision, you have to use. I recommend you to use OpenCV. Of course, there are many others packages, but OpenCV is on top. And let's start to see how to read the images in OpenCV. Before using any libraries, we have to import it firstly. So import CV CV, because I don't need to add this to for every uh, code. Or you can also use OpenCV. You can use this as well, but to make it short, just use computer vision CV. And from pill import image. So for now we need also this. And now how to read the images? Image CV equal CV dot mread, and we have to add the directory. Okay, image one. Okay, so because I have it already in the directory, so I can read this one here. So now after reading the image, you have to do this every time, and it's indeed recommended. If is none, if there is no image in the path, because OpenCV will give you no issue, no error. It just try to read the image. If there's no image in this directory, it won't give you. It just give you image CV. Let's see none, and it won't give you any exception. And here we can see raise. We can also try and catch, but we can see it next time. The next for the pillow. And let's see here. We can see no error. Image not found. Just like this. And let's try now. You can see it's reading the image. And if there's no image, let's just change this to 10. because I have no image called 10. This will, that's why I have a exception. So now let's see, read it. Now let's print some features of the images. So let's see printing the shape of the image, and the shape of the image in OpenCV, it will be height, width, and, and channel, sorry, and image CV dot shape dot shape. So now if I print this, you can see here I have this image dimension, the width, height, width, and the, the number of channels, red, green, blue. And I can also print data type. Let's see, image type. So for this you need to use image cv dot d type. And what we also interesting in how many elements in this image. Let's see, image size. It can show us image dot size. So what is the difference between size and shape? So the shape will give you the dimension, and the size will give you how many elements in this image. So let's have a look. So you can see this is the image shape, and this is the type of the image, and this is the image size, which is how many elements in this image. If you multiply these three numbers, you will get this value here. Now let's try to read the images with pill. So let's see, image dot open. So let me just copy the path from here. Mm. So I'm now opening the image. Now print. Let's see, pill image size. Yeah, image mode. Let's see, image mode. We can use this if hopefully we will remember this string. So image pill dot mode. What is the mode? Do you think the mode is it colorful or gray? And you can see the size, and here the size is different. I will just show you. Let's see, image pill dot size. Now we can see the image pill, sorry. So the image pill, you can see that it's red, green, blue. You can see here it's here we have three channels, and we have three channels, and the size is, as you can see, the size of the image is different from the OpenCV. Here we start with height, and here we start with width. So this issue I have it had for me several hours to recognize this features or this issue. And also I by the way, you can also, before, let's see, after the reading the image, you have to add this try catch, or maybe this one here, if have to add this function to this statement. So let's see, try and use catch. Accept a catch in C++. File, open source. Let's see here, print. I can just fix the indentation once I finish. Error. Then you have the image not found. So we need just to make the indentation here, and this one will try to read the images, and you can see if there's no image we can get some exceptions. let's see, for instance, if we comment this out, see, and let's see, I'm just changing to 10. So this will let you know that the image. Okay, so here it's also give us exceptions in the pill. Okay, so let me just back the stuff here. And did you catch that? So OpenCV gives us a NumPy array with a shape, height, width, and channels, while Pill or Pillow gives us a special image object, and the dimension, the size of the image is starting with width. And as you can see here in Pill, there's no dimension. I mean, there's no channels adding to the, but we can get the channel. Let's see how many channels we're using the Pill mode. And also notify that Pell is reading the images in red, gray, and blue, and OpenCV, we will see it, it's in blue, green, red, green. So let's see, blue, in OpenCV, it's blue, grid, blue, green, red. So we will see it in the next video. In the next, now how to display these images in OpenCV? You can use cv.mshow, and we need to add the name of the OpenCV image, the name of the window, because OpenCV will create or initialize a window for our image. Now we can add the image you would like to show, and before this, don't forget to add the key, the weight key. So let me just run this and show you. Here you can see I can't see any image, and I can control it. So for this, you need to add let's see, comment this out. Let's say to add the cv.weight key, and weight key, let's see, 0. If it's 0, it will be infinity unless we have destroy a window. So now you can see I have it here. Why we added 0? So if I add 20 milliseconds, it will be too fast. Let's see, 2000, 2 seconds, 2000 milliseconds is 2 seconds, and you can see here is showing, and after 2000 milliseconds, it will be destroyed. This is just to show you how to save, handle the image. Sometimes you don't need to keep the image open until you have to close it yourself. So add just time. Time. And how to add it in how to show it in a pill image dot show. So you can see here. So you see the difference, right? So OpenCV create a window that control, let's see, programmatically, while Pillow is just open our default image viewer. This is my default image viewer, and this is Pill. It's just using this one here. So this somehow makes OpenCV better for interaction application, where you need to display images as a part of your program flow. So, and also as a tip, so weight key is essential. As I said in the beginning, this one here. Without this, your window will be flash and disappear instantly. This 0 means wait undefined, let's say, indefinitely until a key is pressed. And this one you have to close it yourself. Now, the new features of OpenCV is reading videos or just capturing the images from webcam. So this feature is not, let's see, found in the pill or pillow. So how to do this? We have to add this capture c dot video capture video capture, yes. And here we need to define the index of our camera, of our webcam, and the default one, let's see, is 0, and maybe to be honest, once I have several images, several webcams connected to my device or PC, I will not able to, let's say, to recognize which index is which to use. I have to run to try all of these indices. So now, because we're reading a video, we need to have a while loop, and a while loop, it will run infinitely until we have say stop. So we will see when we need to do stop, return, and frame it's equal cap dot read. So this function here, this function in the beginning, this line here is open a connection from to the camera from OpenCV and camera. It's just opening a connection without any images. Now when I see while loop, I mean inside a while loop, I have a loop, and with this function here, it will try to trigger camera to get 1 frame. And after reading this, I have to see if not return break. So this line will give us a return value, which is a boolean value, and the frame. If there's an image, this will be true, return will be true, and this will contain the image itself. And if there's no connection or there's no index camera 0 or 10 or etc., this will be false and the frame will be none. So now let's see, I have this 3. Now let's see, I need to show this image. See, show as usual. Let's see, webcam, and we need the frame. And let's see, I have to add this if cv dot weight key 1 and equal odd q. So this will run infinitely until I have, there's 2 conditions. So let's see, if there's no image, it will be breaked. If I have clicked a Q, or let's say press a key Q button, this will stop. And also here I have to capture dot release, and also cv dot destroy all windows. So you can see here now when I open this, because I have a camera, but it's showing us a black because it's closed. And you can see now if I press Q, it will be closed. Now once someone will see why we need this while loop until we just showing the image. Of course we can add what if you want here. For instance, let's see, we need to convert this frame into grayscale image. CV convert color, and we have to add our frame, and also CV dot color gray. This one here, it will be converting from G. Oh no, there are many functions indeed here. I have to add red, blue, green to green. Yeah, this one. You can see color convert this color to this color. No, to gray. This is the right one indeed. And let me just show it here. And for that, let's see, call this window as a gray image, and also this gray image, and let's run it again. Why is this? Oh man, yeah, because I have no images, so you can't see any stuff. Because this is the webcam and this is the gray image. So now I have to press Q to kill this process. Of course, here you can use, for instance, you wanted to detect the canny edge detection, and for the wait a second. And this is how to get image or capture images from webcam. So if you have a video, of course, you can just use, will be the same except just adding this line here. Instead, just replace this with this. So here we will see. So as you can see here, we are not just displaying in this once we're reading the video, we are just not displaying the images, the video. We are also processing each frame in real time. And this is the foundation of everything from face detection, anomaly detection, augmented reality, and everything. So you have a video frame and you can process this. And for the real time, maybe let's see, just assuming the processing the processing of each image, it take, let's say, a long time. I mean, more than the capture. The capture is just on fly, let's see. And the processing, let's say your processing, takes, let's say, 2 seconds. I mean, 2 seconds is too much. Let's say 500 milliseconds. And in this time, you will skip many images. So the ideal the ideal solution for this is to keep these images, capture the images, and keep it in a list, or let's say in a queue. And once you finish the processing of the previous frame, you can get the images from the queue. This is what we done, let's see, normally. So, but we will talk with this topic in the next advanced videos. And this is, let's see, a real time processing capability. This is why OpenCV is, let's see, a good solution for this. So as you can see here, we see the video is just, let me just copy it like this and remove this, and this is the code for capturing the video. So if you have a video, I have no video here indeed, and you can just read the video. And by the way, you can also reading the images and do some processing and also saving the results in a videos. So you can also do this. And how to save the images in an OpenCV? What you can do is CV m write, and here let's see, you see output 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 dot png, and we have here mcv. Sorry. And with it, let's see, just have output cv, and here we need to add, how to do it here, it's also the same, but you see dot save dot open dot save. So here we have open, and you can see here cv image right, the image name and the image itself considered as parameter, and here is it's considered as a class, so it's image dot save, and this is an image name. So let's save the images and see if they are identical. Okay, it's not here. So let's see, explore. So this is the OpenCV image, and this is not this one. And where is this? Oh, I have to change, sorry. Pill. And now let's see, this is the image. This is the OpenCV image, and this is the pill. It's exactly the same. Okay, so let's see now. The next topic is common image operations, and this is let's see fun part I will see. So now for the reality, so for we need, let's say, some programs we need to transfer the images into some other, let's see, for instance, resize, and also maybe rotation and etc. So let's do some converting. We have already did this converting to grayscale. By the way, yeah, so let's see here the image. I can just copy this, and I have read the image. What was the name of the image? MCV, yeah? Right. So this is image CV. Let's see here, CV. And for the gray pill, you can use image pill dot convert, and you can add this here, L. So L is the grayscale image. So we will see now how to show the image. Oh, yes, you can see it. Where is it? Here. So now if I see pill, gray pill dot show, you can see it's converted to grayscale. And with the OpenCV, we need to use this one here. And for the resizing the images, so let's see resized CV. We have to use CV dot resize, and here the input is image CV, and then the size has to be in this as a tuple, and let's see 200 200 200, and also the resized pill, it's image pill dot resize, the same resize, and here you need to add as well in a table, otherwise you will get issues. So let's see here, and let's see open, just to show the image resized. You can see it's resized this images. So this is how to do stuff. I mean, how to resize, how to convert the convert to grayscale and etc. Now let's see, you need to rotate the image. So in OpenCV, it's not that, let's see, straightforward, but we will do this. So you need, let's see, the rows. Let's see, we need rows, columns is equal image CV dot shape, and we need the shape, only the shape width and height without the dimension, the channels. So you can just get this, or you can, let's see here, dot, yeah, this is the easiest way. And now we need to use the function get rotation matrix 2D. So for this we need, let me just open, I'm just forgot how to get rotation matrix 2D. Close. We can get this one here. Let's see, M because we have username. The center is columns divided by 2 and rows divided of course by 2. This is the center. Let's see, keep this as one value, and the angle is, let's see, 45, and the scale is 1. Just keep it as it is. Its rotation is 45. Now rotated CV is equal CV dot, I think, fine, yes, and here image CV M and rows columns. So let's see, and for the pillow, rotated pill is equal image pill dot rotate and 45, and of course you can see the image of the rotated. You can see now here it's rotated 45 degrees, and also of course you can add, you can show rotated, sorry, rotated CV, show rotated CV, and here we need to add weight key 0 CV dot. This is the destroy all window. So this is the set find you see of. So but let's see. Okay, I want to see the pill. It's the same, but I have, because the program is running sequentially. I can't see it until I kill this. I'll close this. So now I can see the pill. So it's just to give you an idea. It's these are the same. So let's say sometimes you need to create an empty image in OpenCV, and to do this we have to import numpy as nb. We need to have height, width, and maybe also we can see the, let's see, 400 and 400. The channels we can identify it here. It's either 3 or 1. But let's see, black CV. Let's see, numpy dot zeros, and we get the dimension in a table. So please don't forget this: height, width, and of course the channel is 3, and maybe you need the type. Let's see, DT type. D type is unsigned n, unsigned int 8. Oh, I need to add numpy dot. So this will create a black image, and if you would like to have it, let's see, white image, what you can do is just, let's see here, instead of zeros, just write ones. Easy, huh? White. And we can also use this. Let's see, just copy this one here for the OpenCV to see the differences. Let's see, black, also show white, and we can see all of these. Why all of these blacks? Let me, why it was showing, let's see, print, just to see the pixels value, print white. Okay, one to see the full the black, the white image, we have to multiply it by 225, 255. So in this case we can see the white image. So let's do it. Yes, now you can see white and black. So I mean, sometimes it's not working, just you need to debug or printing the image and see what is going on. And for the pill, let's see, just add it here, pill. From this we need, let's see, a black pill is equal image dot new, and we need, let's see, defined the mode is red, green, blue. Hopefully this is right. And here we need to add the width. You can see width and height. What's wrong here? Okay, yeah, I got it. Because here we have using this name, the parameter name, we have to use it in the next one. I have already discussed this in the functions, but this is not our problem. And also here you see we have 3 channels, and also you can do it also with only one channel. This should also work. Q. So adding only 3 or 1. But for the for the payload we have to add this, or maybe, let's see, not gray. You have to add here L. And for the colors we need, let's see, this one we need to, for the colors it's black or white. This is a black color, black one. And for the white we can add, let's see, white. We can add here color is equal white. Let me check, and let me just check this dot show. See the black, yeah. So without multiplying by 255. So this we already defined it here. So this is the, let's see, the how to create an empty image. So sometimes it's needed. So the tips and tricks and best practice. So as you can see, what? So let me just create here one markdown. Let's see, red, green, blue versus blue, green, red. So this is the OpenCV is read in this format here, blue, green, red, and this is the pill. And now we need to convert between these and these. So how to do this? Let's see, red, green, blue is equal cv dot convert color, and here we need to add the m. Okay, mcv, now cv dot color blue, green, red to red, green, blue. Yeah. So now this will convert the image from red, green, blue. And if you want to see the difference, let's see, we need to show this here. Hopefully we can see the difference. Let's see, this is the and this is the red, green, blue. Let's see here, blue, green, red. See, when we change only the channels, the image is different. So if you, let's say, mixing between this pill and OpenCV, you won't be, let's say, expect any, let's see, you can expect any differences, any deviation. So try to stick with one, either this or this. So see, if we just change the channels, we can use we can have different results. So this is just to show you how to convert the colors. Now we need to convert, let's see, at a markdown here, convert between them, conversion between this. For instance, if you have OpenCV, can we convert it to pill? Or if we have pill, can we open it to into convert it into OpenCV? Yeah, this we will see. Now let's add a code here. So now we already have OpenCV. So now OpenCV, let's see, what's this? Pill to CV. Pill to CV, just like this. What we can do is n by numpy dot array, and we can use image pill. So we can convert the this is the image, that is pill image, right? And we can convert it to OpenCV only with using numpy dot array. That's it. And let me just show you. We need to see. So you can see it's converting. This is the, let me just see the image. Dot pill dot show. Sorry. So you can see this is the image of pill, right? And this is converting to OpenCV. Now, if you can see, print what's the pill to BC dot shape, just to see the shape. And let me just comment this out, also this out. So we need to see the size, and the size is the same, but I mean the channels are different. So to convert it, I mean, after converting to OpenCV, what we have to do is, let's see, this. Let's see, we need also to use this. So in the beginning, you can see just like this, and you can see OpenCV. It's converted from pill, but with channels are different. So we need to return it to the default of the OpenCV. To do this, we need to see cv dot convert color, and here we need the pill to OpenCV, and you can see open color dot color red, green, blue to blue, green, red. And now it should give us, let's see, the original image, as you can see here. So now after converted from pill to OpenCV, the channels will be changed. So now we need to convert it to the original OpenCV image format. I mean, channel ordering. So this is, let's see, now how to convert from OpenCV to Pill. So with this, so here we have our OpenCV. So you can see, mm, first of all, we need to convert the images, so the channels. So let's see, I'm using the first image OpenCV. This is haven't been touched, HTC, and now I have to convert it vice versa. Big green to green red to red green blue. Yes, this one. So now I have to convert it. So now vice versa, CV to pill. So now in the beginning I have to convert the channels into red, green, blue. Sorry. And now let's see, I will add this function. It will be image dot from array, and I can add this. So now if I see this dot show, or maybe before this I can show also the difference. See now, what is this? Ah, yeah, no, I have to convert it. So let's see, this is the original image, right? And if I just see image, will it work? Yeah, see, the channels are different. So that's why we need just to convert the channel. So if you are working with these two images, yeah, I have to add this. If you have to be working with OpenCV and Pill, so you have to take care of this image ordering, I mean channels ordering. So now here we need to make somehow benchmark what is the best. I mean, not what's the best. We know OpenCV is the best, or let's say fastest performance. But just to give you how to do stuff. So let me just import time. I have also showed you how to do it with the decorator function, but here I will just start with the normal one. So start time, to time, or maybe okay, time to time is fine. Time to time, or maybe we can see from time, import time, and we need only one. And let's have a look. Let's have for loop. Let's see in range 10, and we can see now. Let's see, I'm trying to open the image, cv dot mread and here I have to add the data. Oh, sorry, image 1. So I'm trying only to read the image 10 times and see what is the fastest let's see way. I mean OpenCV or this. And let's see here, print. I can add if and OpenCV, and we can see here time minus the first time, start time, and also in a float for float, and here we need to add a second. So this is to show you the time to calculate it in when you read 10 images. And let's do it for the same. We also need from scratch, so this one here, and I can also use image dot open. Just remove this, and now we see pill. Now let's see the time. If I run just this, what's wrong here? Read. What's did I change the number array? Did I import CV2 as CV? Ah, man. Okay. See, big issue here where you just use this variable while it's already used for the OpenCV. This is really wrong. Say, let's say time. And here we need to add, let's see, CV image, the right word. And here we see pill. Now let's calculate the time. Again, because we already, when you run this one time, it will save the variable as image. Oh. So now we have to import this again. What? Pill is better than OpenCV? No way. Let me do this 20 times. No way. Oh, okay, I forgot. So we have to add here pill to compare apple with apple. We have to load image. So because when you read this, when you add this image read, it's just open a connection. It's like a connection without reading, and it will start reading when you add, let's see, any comma, any comma, any. If you would like to use this image, it will try to load it automatically. I mean, after this command, but this command it's just only as a pointer. So now we can see, yeah, this is clear. Okay, and here I have 2 and here I have 20, which is even better. So you can see now OpenCV it's better, but because here it's only one image, it will make any big difference if it's used for several many images. And yeah, so as a, let's say, comparison between pill and OpenCV. OpenCV, the color space is blue, green, red, and pill is red, green, blue. Just image type is numpy array, and this one is pill object. Supported for video, no, for the pill, and the performance is high, and the learning curve is steeper and chin. This one here you need to be, let's see, professional. Not a professional, but with this course you will be a professional, I'm quite sure. And this is now the next one is important question just to test your understanding. How do you read image with OpenCV, and how do you display the images and etc. So this is somehow let's see, Interesting question just to check your ability. And this is a multiple choice questions, and this is the answers. And if you like this video, please subscribe into my channel because preparing this, you can imagine it took a lot of time. And yeah, of course, if you have any question, just drop it down in the comment below. And thanks for watching, and see you next time.